Hello everyone, myself Akshata, roll number 25 from TY Electrical. Name of subject is switchgear and protection. Today's presentation topic is protecting relay. Now what is protective relay? A protective relay is a device that detects the faults and initiates the operation of the circuit breaker to isolate the defective elements from the rest of the system. Now requirement qualities for protective relay. First, uh, first quality is selectivity. It is the ability of protective system to select correctly that part of system is in trouble and disconnect the faulty part without disturbing the rest of the system. Second quality is speed. The relay system should disconnect the faulty section as fast as possible to prevent the electrical apparatus from damage and for system stability. Third quality is sensitivity. It is the ability of the relay system to operate with low value of actuating quantity. Fourth one quality is reliability. It is the ability of the relay system to operate under predetermined conditions. Fifth one is simplicity. The relay system should be simple so that it can be easily maintained. Sixth one quality is economy. The most important factor in the choice of particular protection scheme is the economy accept. The protective gear should not cost more than 5% of the total cost of equipment to be protected. Now some fundamental requirements of protective relays are: detect abnormal conditions, disconnect abnormally operating parts so as to prevent the subsequent fault, disconnect faulty part quickly so as to improve system stability, service connectivity and system performance, improve transistor stability. Qualities of protective relays are selectivity, speed, sensitivity, reliability or trustworthiness, simplicity and economical. There are classification of protective relay. Now based on characteristics, the protection relay can be categorized as definite time relay, inverse time relay with definite minimum time, IDMT with instantaneous relays, step characteristic, program switches, voltage restraint over current relay. Now second classification is based on actuating parameter. The protection relay can be categorized as current relays, voltage relays, frequency relays and power relays, etc. Third one, third one classification is based on application. The protection relay can be categorized as primary relay and backup relay. Now there are some important terms of relay. That is, first one is pickup current. It is the minimum current in the relay coil at which the relay starts to operate. Second one is current setting. It is the often desirable to adjust the pickup current to any required value. This is known as current setting and is usually achieved by the use of tappings on the relay operating coil. And this is the image for current setting. Now third one is plug setting multiplier, that is PSM. It is the ratio of fault current in relay coil to pickup current. PSM equal to fault current in relay coil by pickup current. Fourth one is time setting multiplier, that is TSM. The adjustment arrangement provided for setting the operation time of induction relay is known as time setting multiplier. Fifth one is reset current. The value of current below which the relay resets and comes back to its original state is called as reset current or dropout. This is the power curve for plug setting multiplier. Figure shows the curve between time of operation and plug setting multiplier of a typical relay. The horizontal scale is marked in terms of plug setting multiplier and represents the number of times the relay current is in excess of the current setting. The vertical scale is marked in terms of the time required for relay operation. If the PSM is 10, then the time of operation from the curve is 3 seconds. The actual time of operation is obtained by multiplying this time by the time setting multiplier. Now, next is introduction to static relay. The relay which does not contain any moving parts is known as the static relay. In such type of relays, the output is obtained by the static components like magnetic and electronic circuit, etc. The relay which consists static and electromagnetic relay is also called static relay because the static units obtain the response and the electromagnetic relay is only used for switching operation. Now this is a block diagram of static over current relay. Now what is static type over current relay? The current derived from the main CT is fed to the input transformer which gives a proportional output voltage. The input transformer has an air gap in the iron core to give linearity in the current voltage relationship up to the highest value of current expected, and is provided with tapping on its secondary to obtain different current settings. The output voltage is then rectified and then filtered at a single stage to avoid undesirable time delay in filtering so as to excuse high speed of operation. A Zener diode is also incorporated in the circuit to limit the rectified voltage to safe values even when the input current is very high under fault conditions. A fixed portion of the rectified filter voltage is compared against a preset pickup value by a level detector, and if exceeds the pickup value, a signal through an amplifier is given to the output device which issues the trip signal. Now there are some advantages of static over current relay are low power required, hence less burden, no motional parts, hence bouncing, friction, erosion, arcing, etc. eliminated, not affected by gravity, may be used in any position, improve selectivity as resetting and overshoot times is reduced. Lower operating times. One static relay can be used for multiple purposes. Higher torque or weight ratio, compact in size, good discriminating characteristics and reliability, suitable for reliable remote operation with PLC, and last one is can be programmed as per requirement. Now some disadvantages and limitations of static over current relays are affected by voltage transition, affected by electrostatic discharges, sensitive to temperature, auxiliary power supply is needed, higher skill manpower required to handle or program or install, operating characteristics may be affected by operation of output device. Applications of static relays are ultra high speed protection of EHV-AC transmission lines utilizing distance protection. Second, in overcurrent and earth fault protection schemes as main element in differential relay. Now this is the block diagram and working of microprocessor based on overcurrent relay. The AC voltage proportional to the load current is converted into DC through a precision rectifier. Thus, the microprocessor accepts DC voltage proportional to the load current. The schematic diagram is shown in the figure. The output of rectifier is fed to the multiplexer. The output of multiplexer is fed to the AD converter to obtain a signal in digital form. The AD converted ADC0800 has been used for this purpose. The microprocessor sends signals to the ADC for starting the conversion. The microprocessor reads the ends of conversion signal to examine whether the conversion is over or not. As soon as conversion is over, the microprocessor reads the current signal in digital form and then compare it with the pickup values. The microprocessor first determines the magnitude of the fault current and then select the corresponding time of operation from the lookup table. Then it goes in delay subroutine and sends a trip signal to the circuit breaker after the predetermined time delay. Now applications of microprocessor based relays are these relays are used for modified existing protection system. These relays are used for new substations or transmission lines and they are very cost effective. Microprocessor based relay used for include communication scheme logic. These are used for relay record the system condition and performance analysis. And these are also used where programmable logic allows the user to define the operation of the relay. Thank you.